All right, we are going to review this one for chapter 6. People want to go over number 1 on the worksheet for chapter 6, and then I'll go over the answers for the other 2, but then we're going to move on to chapter 7. So, this one, what did I get rid of? I told you should probably get rid of your A's. Why? Why did I say get rid of the A's?
I don't know.
I know. We did do it at the end of class? No, we did this at the end of class. We got rid of A because it's a whole number, right?
Yeah.
And we ended up with the answer of 1,500. Ooh, that is not a 5.
Did I lose that paper?
I don't know. Something's going on with you, girl. 1,500 comma 700. If you change them to X's and Y's, and if you left them C's and A's and then put them in alphabetical order, you had 700, 1,500. I will accept both answers if you had the correct numbers. Okay? Great. The next one that we had was 1/2 x plus 3 y equals 2x. What would you use for this? Really fast. Graphing. When I graph this, what's my y-intercept for the second equation? Wait, what? What's my y-intercept for my second equation? This one right here. Plus 0, so my b is 0 here. And my m is 2/1. Nice job, Tig. Okay? Amy, put that away. Then I would graph this. If I graph this, I got 2 comma 4. If you did not get that, you need to talk to me while I'm walking around while we're doing some work. Okay? If you did this one, Eric and Kevin, you should have got an answer of 11 and 5. If this is the last one, we had to, nope, did not have to do this one. This would have been 4 and -2. If you did it. And then this last one we did in class should have been 8-4. Do we need to go through that at all? No. Fantastic. What did you use for this one? I did too. Yep. That answer or this piece of paper? You did it yesterday in class, girlfriend. Yes. Okay. It looks like this.
I got -8.
Nope, the other one.
Oh.
If you got -8, then you got the wrong answer for y. Here's why you got a -8. That's a -x. So when you distribute this 3, that would have been a -3. Yes?
Yeah.
So then that would have changed it to -8 or to +8. Actually, no. Yes, +8, and then you should have got 4. Yes? That was the error other people made. The last one was that one. The last one was this one. You should have got 2 3/2. Or 1.5. 2 3/2 or 2 and 1.5. Questions on that one?
What about your 1.5?
8-4. 8-4.
Okay.
Questions on chapter 6? Which one?
What was
The first one? We did it at the class yesterday. Yes.
You just told us the answer.
No, we didn't. But I'll do it with you when we're not on video. Yes. Because we did do it at the class yesterday.
What's the error?
Eric and Kevin is 11 and 5. So Z, yes, I will do it with you, but I want to start chapter 7 so people can get on that first, okay? All right, you just received your chapter 7 review. Okay? Exponent rules are our friends. We like them. They are what we needed to do the rest of the year for our factories, things like that. Jerry, take your foot off. Jerry, face over here. Jerry, get your piece of paper out and start writing. So chapter 7. No, just going right at him. Chapter 7, we're going to get after right away by starting with the rules. Okay? You have a little flip book somewhere. Carlos, stop talking. You have a little flip book. Elena has hers showing so that you can see what it looks like. You might want to get your flip book out or just write down your rules. It's okay if you don't have it. Let's not worry about that. Let's just worry about getting started. So in my rules, when I was multiplying an exponent that had the same base and different exponents, or even the same exponents, but they have the same base, and I'm multiplying this here. I just told Jerry to take his foot off, so you should take yours off too. Thank you. What is my rule? My base stays the same. My base does not change. What am I going to do with my two? Add them together. So I'm going to do m plus p. I can only do this if it's the same base. If this was an x and this was an x. If this was an x and this was a y, then I don't combine them. Okay? What was my rule if my exponent was being raised to another power? What did I do with my exponents? Multiply. My base stayed the same, and I did m times p. Okay? Tomorrow I'm going to be giving you your cheat sheet. You are going to work on it over the weekend. It must come back. If it doesn't come back, that's on you, and you will not get a new one. Okay? These are something I would probably add to my cheat sheet, for sure. The 3 different methods, especially elimination, maybe the steps for how to do elimination might be a good thing to add to your cheat sheet. If you go back to your notes from chapter 6, we had a step-by-step process. If you don't have those notes, you can go back to the video or back to the chapter 6 folder in Schoology and find that. Okay? You guys are going to have to study for this exam. I expect you to do better than D's and F's on this exam this time. Okay? You've got to work at it. This is a final exam that you need to take seriously.
Everybody said
We got it.
Everybody said you can bring your grade down later.
Good if you do really, really poorly on it.
You can make your grade up.
Sure it could if you do really well on it. Yeah. Okay? So take it seriously. Actually study. Do problems. Do these problems over again. You know the answers. Cover up the work and do the problems over again. Okay? Your reviews aren't being graded. They're simply for you to make sure you know what you're doing. If you can do everything on these, you'll be fine. What's my rule for this situation? I have 2 things being multiplied together and then they're raised to a power. Okay? So essentially, it's the same rule as this one. It's the same one as this one. But the exponent on my a is 1, right? And 1 times m is m. And my exponent on b is 1. So 1 times m is m. So we can successfully take care of that. Good? Questions on that? What is my rule for a to the m divided by a to the p? What did I do with my exponents there? Here when I multiplied, I added my exponents. Here when I'm dividing, I'm going to do the opposite. My base still stays the same, but I'm going to do m, the top one, subtracted by the bottom one. Right? You need to go good order. Make sure you're in the right order when you're subtracting, because it makes a difference. Yes? You would subtract the m and the p, and the letter, the base would stay the same. So if this was x to the fourth and x to the third, well, second, you would get x 4 minus 2, which is x squared. Okay? Alright? When I have this situation, it's kind of like this. Right? What did we do? We kind of distributed that in, so we're going to have a to the m times n. And then we're going to have a to the, oh, that's not an a. There we go. The p times n. So this is just going to distribute into those. And it's just the same thing as the rule up here, right? Like, if this wasn't here, it would be the same rule. So we're doing the same thing. Good?
1.
A to the 0 is always equal to
1.
1. Anytime you see anything to the 0 power, you need to put a 1 there. And then, you're going to multiply that out. Don't leave the 1 there in your answer. Okay? We don't need the 1 there. Alright? Questions? This is the one we struggled with.
1 over A.
So remember, this was our stay and go. Remember stay and go? So this is essentially over 1, right? We don't want to have that negative exponent up top. We don't want to have any negative exponents. So if it starts up top, it needs to go to the bottom. And then that negative part goes away. Everything else stays the same. If it starts on the bottom, if this was negative, it would have to go up top. Okay, we'll do a couple of those. That was the, does it stay, does it go, does it stay, does it go? What do we have to do? Okay? Questions on the rules? Fantastic. So now, here's what you need to do. Each of these problems, you need to look at which rule am I using, apply the rules, simplify if you can. Sometimes 2 steps. If these both would be x over each other for number 3, this would be x squared and y and x to the 5th, then you would first take care of this and then take care of your division. You have to use order of operations when you're simplifying. And you're going down order of operations. You're going down behind it. Okay? So are there any parentheses? Are there any exponents? Yes. In all of this, there's going to be exponents. I would like you to do those first problems really quickly, and then we'll talk about it. Go. What rule did I use for number 1? What did I get for an answer? What rule did I use, and what did I get for an answer? What am I doing?
The product.
Product rule, and I did what with my exponents? What do I do here? What did I get for an answer? I added these, so I did 4 plus 3, right? So that would be some work that you could show. Do you need to? No. You can skip that step and just give me m to the 7th. I have to take care of my coefficients. Anything that's multiplied, we know how to multiply negative 2 times 5. That doesn't change just because it's got an exponent on it. The negative 2 and the 5 are separate from the m. They are separate from the m. You deal with them differently. Okay? What did I get for number 2?
4x power 6.
Is it 4x to the power 6? Did somebody get a different answer? What did you get? 84. 384. How do you get that? What do I have to do with my 3?
Oh, it's up to you.
I have to distribute it to the exponents. The 4 also has an exponent on it. It has an exponent of 1, so I need to multiply that by 3. So I'm showing you the long steps to do this so that you see this. It might be a good idea to write them down so that you see where we got the answer. Right? 4 to the 3rd x to the 6th. But I need to figure out what 4 to the 3rd is. Do you remember how to do that on your calendar?
It's not in there. Yeah, I don't have to do that on my calendar.
Wait.
Calculator? Did I really just say calendar? Apparently, these last 8 days are gonna be long. No. You're multiplying the power. Okay, so not a calendar. 64. This is 4 times 4 times 4, right? Or on our calculator, we can do 4 caret 3. Remember the caret button?
Oh yeah, I do that on my phone.
So I've got 64x to the 6th. This is my answer. Then 3 needs to go to the 4 as well.
That's what I said.
Okay? How do I, what did you get for number 3?
X power 6 over 5.
Okay? And she got that by, we're going to do 2 times 3 because we're going to distribute this. We're going to do 5 times 3. And x, that gives me x to the power of 6, y to the power of 15. Do I have to reduce anything there, or am I all done? Is there anything, are these the same base? No? If they were the same base, I'd have to subtract my exponents, but they're not, so I'm done. That's my answer. What's the? Everybody sees this? Yes, no, maybe so? Give me where you are. Thumbs up, sideways, down. Brooklyn and Z are too busy on their phones. Number 4 is a fantastic example of doing order of operations. Okay? I need to first take care of my parentheses. Then I need to take care of my exponents. But to take care of my parentheses, I also need to take care of my exponents. So we did a problem like this top just a second ago. It's just like number 2. It's just like number 2. So I'm going to distribute that in. So I'm going to get 8 squared, and m is going to be 4 times 2, right? Is anything going to change on the bottom? Why not? It's already simplified. The parentheses are just on top, so I just need to simplify that. But I might need to go one step further after I'm done. But let's do that. So 8 squared is 64. M to the 4 times 2 is 8. It's all right. Then I've got 24, m to the 4. Can I reduce this 64 to the 24? Can I divide both those by a number? 8, right? So how many times does 8 go into 64? How many times does 8 go into 24? 3. What do I have to do with my m's now? So I took care of my numbers. Now I have to take care of my m's. They're separate. So subtract. So what am I going to get? 8 minus 4. Is that going to end up on the top or on the bottom? Why? Because it's positive. If my 8 would have been on the bottom and I would have had to do 4 minus 8, I would have got negative 4. Where would it have ended up? Bottom. Okay? Here's a good example of that. Number 5, what did you get for an answer? X to the negative 3rd power. So I did x 12 minus 15, which gave me x to the negative 3rd power. Can I write my answer like that though?
No, but you can put the 1.
I can. I can put my 1 on top and scoot that bad boy to the bottom, and then it becomes positive. Right? The only reason the 1 is there is to hold the place of the empty space that we moved this from the top to the bottom. Okay? But the 1 has to be there, otherwise it's not a fraction. Number 6 is a really good example of applying what we've just done in these couple of problems. Do you mind if we take care of the fraction right away? 25 and 10, what can we divide both 25 and 10 by? 5. If I divide 25 by 5, what do I get? 5. Divide by 9. If I divide 10 by 5, what do I get? 10 divided by 5 is 2. See where my 5 halves came from? Okay? Now I'm done with that. Now I need to deal with my B's. And if they're not in the right order, like if I have a B here and a B over here, I still need to deal with my B's. Okay? All right. I've got, I can't read that number, 8 and 4. B to the 8th, B to the 4th. What am I going to do with my exponents, first of all? Subtract. And I'm going to do 8 minus 4, and I'm going to get 4. So my B's are going to end up on top or bottom? Okay. My C's, now I need to look at my C's. What am I going to get? 3 minus 9 is negative 6.
It'll be on top.
It?
Yes. Because it's supposed to be at the bottom.
And when it's C to the negative 6, that's because it's on top. So everything's on top if I subtract my top number from my bottom number. Okay? So C to the negative 6 would be on top, so we have to move it to the bottom. Let me show you a trick. 9 is bigger, right? Where is it? Bottom. So wherever the bigger number is where your variable is going to end up. And then you can just do 9 minus 3. You can do the bigger number minus the smaller number, but then it ends up on the bottom because that's where the bigger number started. Okay? Matrices. We got 3 minutes, so we're going to try and do a little bit more. We're going to talk about this one tomorrow. I'd like you to try this one. This answer is this. We never did anything with addition. So C and D are your ones. This. How do we rewrite this? 256 to the what?
Tell your beautiful creation.
How do we rewrite that? What? To the power of 4? Not to the power of 4. Do you remember this?
Very good.
To the 1/4. Whatever this is goes 1 under 1. And then we do this on our calculator. 256, here it, parentheses, 1 divided by 4, parentheses, equals. Come back with an answer for that, please. When I do my matrices, what am I going to do with my 8? Distribute it. So my first number is going to be negative 40. I'd like you to figure out the rest. When I subtract, what am I going to do with my numbers? Remember, I subtract this one from this one. 7
Please
minus 6
excuse
is?
this quick interruption before we break for resource. Once again, all students that will be sophomores,
Finish
juniors, and
matrices for
seniors
homework.
next year for the 22-23 school year. If you're interested in or planning to participate in a fall sport next year, there will be a quick sign-up meeting today during resource to meet with coaches to get any important summer
This
information
one?
planning
If you want to rewrite it
Current
the way we
seniors
are used to
to
looking
the
at it,
cafeteria. If you're not in resource, please. Football, you will meet in the gym with Coach Hobbert. Girls tennis, Group 104 with Coach Colmorgan. Volleyball, 109 with Coach Raymond. Cheer dance in the student
you're
center
used to
with Coach
looking at it
Myers.
like this.
Boys
Your
soccer, cross
answers
country,
over
and
here,
girls swim.
here,
You will also go
here,
to the cafeteria as well.
So
Thank you.
you decide which way you want to do this. Do the back. Look at your notes from your chapter to do the back. Okay?